Here we have two functions of f of x, both of them are linear. The one on the left, f of x, is increasing and the slope is positive, and the one on the right, f of x, is decreasing and the slope is negative. This is very important for the following steps. Here I want to determine the relationship between the function f of x and its derivative f prime of x. So notice this. The blue graph is the function f of x. Now I'm going to split that into two segments, left and right. On the left segment, f of x is increasing, and then on the right side, f of x is decreasing. Now to determine the behavior of f prime of x, I'm going to draw tangent lines since the slope of this tangent line gonna be the behavior of the derivative. Here the slope is positive, which means the derivative gonna be positive, and then here slope gonna be negative, which means the derivative gonna be also negative. Therefore, when f of x is increasing, f prime of x is positive, and then when f of x is decreasing, f prime of x is negative. This is also the other way around. So if f prime of x is positive, that means f of x is increasing. Now in case of concavity, note here on the first graph, f of x concave down, and then on the second one, f of x concave up. Now I want to see the behavior of the function f prime of x through this curve. So I'm going to draw this tangent line through the curve. Notice the tangent line in the middle. F prime is 0 since the slope is horizontal. On the left, f prime is positive since the slope is positive. And then on the right, the slope there is negative, therefore the derivative gonna be negative there. So in this graph, as we move from left to right, f prime of x is decreasing. Now in case of f of x concave up, I'm gonna do the same thing. So I'm gonna draw this tangent line through the curve to determine the behavior of the derivative. Starting from the left, the slope there is negative, therefore the derivative is negative. And then in the middle, slope is horizontal, so the derivative is 0. Then on the right side, slope is positive, therefore the derivative is positive. So as we move from left to right, here f prime of x is increasing. Therefore, when f of x concave up, f prime of x increasing, and then when f of x concave down, f prime of x is decreasing. It's also the other way around. So if f prime of x is increasing, this means the antiderivative f of x concave up. Now, between f of x is increasing and then decreasing, we're gonna have a critical point, and this critical point gonna be a local maximum or minimum. And then between concavity of the function, we're gonna have an inflection point. In the following examples, since we are giving the derivative, we want to go backward to graph the antiderivative. So it's a good way to think in terms of f prime of x, since this is the given function. So we have a local maximum or minimum in the function f of x when we have f prime is equal to 0 or undefined, and then we have an inflection point where f prime is the highest or lowest locally. That's a local maximum or minimum of f prime of x. Given f prime of x, sketch the antiderivative f of x. And we are giving f of 0 equal to 0. So here we are giving the derivative and we want to go backward to graph the function f of x. That is the antiderivative. So we're going to follow 3 steps here. 1, I'm going to observe the behavior of f prime of x, where it's positive and negative, and then where it's increasing and then decreasing. Then I'm going to use this yellow note to determine the behavior of the function f of x based on f prime of x. And the third step, gonna to graph the function f of x. Note here, for the whole interval, alpha prime of x is positive since it's above the x-axis. And also, it's a constant. It's not increasing or decreasing. Now, from this yellow note, when alpha prime of x is positive, that means the function is increasing. Since the function alpha prime of x does not increase or decrease, therefore we don't have any concavity in f of x. Now we are ready to graph the function alpha prime of x. Note f of x can just be an increasing function for the whole interval. Note we are given f of 0 equal to 0. That tells us where to start graphing our antiderivative. So here we're gonna start at the origin. Again, f of x is going to be just an increasing function. Note here the slope of this function gonna be equal to 1. Now, to make sure that our answer is correct, what I'm gonna do, I'm gonna take the derivative of f of x and determine if it matches the given function. So notice here, slope is positive and it's constant everywhere. Therefore, when we graph the derivative, gonna be just constant and the value of it gonna be equal to 1, which is the slope. Notice that both of these matches, therefore our answer is correct. For part 2, alpha prime of x look like this, and again we want to graph the antiderivative. So here the first step is determine where the derivative alpha prime of x positive, negative, and where it's increasing or decreasing. Here, for the whole interval, alpha prime of x is negative since it's below the x-axis. It's a constant, it does not increase or decrease. Now from this yellow note of alpha prime is negative, that means f of x is decreasing. And since it's a constant, then the function f of x does not have any concavity. Now, we are ready to graph the function f of x. We're gonna start at the origin. Remember, this is given by the problem. So remember here, this function f of x is gonna just be a decreasing function at a constant rate. And the slope here gonna be equal to -1. For part 3, f of prime of x look like this. Here, notice here, at x equal to 1, the function f of prime of x is undefined. So remember, this is a critical point. So the first step is determine the behavior of f of prime of x. So I'm gonna split the function into two segments, left and right, when x is below 1 and when x is higher than 1. On the first segment, f of prime is positive, and then on the second segment, f of prime is negative, since it's below the x-axis. Here, f of prime is constant, so it does not increase or decrease. From our yellow note, when f of prime is positive, the function is increasing, and then when f of prime is negative, the function f of x is decreasing. And since f of prime of x does not increase or decrease, we don't have any concavity in the function f of x. Now we are ready to graph the function f of x. I'm gonna mark our point here at x equal to 1. And then remember, I'm gonna start graphing the antiderivative at the origin. This is given by the problem. Now for the first segment, it's gonna be an increasing function at the constant rate, and then on the second segment, it's gonna be a decreasing function at the constant rate. Note here, at x equal to 1, this is a local maximum. For part 4, f of prime of x look like this. Remember, the first step is to check the behavior of f of prime of x. Here, I'm gonna split our function into left or right, that is when x is lower than 1 and then when x is higher than 1. Notice the first segment f of prime is positive, and then on the second, f of prime is also positive. Now where f of prime of x is increasing or decreasing, on the first segment, note in here that f of prime of x is decreasing. And then on the second one, f of prime of x is increasing. Now from the yellow notes, f of prime of x is positive. That means the function of x is going to be increasing. And then for f of prime of x is decreasing, that means f of x is going to concave down at this interval. And then where f of prime of x is increasing, f of x is going to concave up on this interval. And then between these two concavity, we're going to have an inflection point. And that's going to be at x equal to 1. So now we are ready to graph our function antiderivative of x. Remember here we're going to start at the origin. So for the first segment, f of x is going to increase and it's concave down. And then for the second segment also, f of x is going to be increasing function, but here it can concave up. And then at x equal to 1, we're going to have our inflection points. For part 5, f of prime of x look like this. Remember, the first step is determine the behavior of f of prime of x, where it's positive, negative, and where it's increasing or decreasing. Here I'm going to split f of prime of x into two segments, when x is lower than 1, when x is higher than 1. Now notice on the first segment, f of prime of x is positive since it's above the x-axis. On the second, f of prime is negative since it's below the x-axis. Here on the first interval, f of prime of x is going to be decreasing function, and then on the right one, f of prime of x is going to be also a decreasing function. Therefore, for the whole interval, f of prime of x is going to be a decreasing function. Now from the yellow note, when f of prime is positive, f is going to be increasing function, and then when f of prime is negative, f is decreasing. And then since f of prime is decreasing, that means the antiderivative concave down for the whole interval. Now notice here, we're going to have a critical point at x equal to 1, since the function is increasing and then decreasing. This critical point going to be a local maximum. Now we are ready to graph our function. Remember, we're going to start at the origin. Remember, at x equal to 1, we're going to have a local maximum. On the first segment, f of x is increasing and concave down. On the second segment, f of x is decreasing and also concave down.